Okay, so when it comes to this problem, we're going to use what we call implicit differentiation. When you're doing implicit differentiation, you want to take the derivative, for instance, of something like this, and you'll do the product rule where it's the derivative of the first times the second plus the derivative of the second times the first. So the derivative of xy squared, the first derivative of x is 1 with respect to x. So you just get y squared here. And then for the second part, you're taking the derivative of y, but you're doing it twice because you can't take just because y is a function, you're assuming y is a function of x. That's why it's implicit. So you're taking derivative of y squared will be 2y times the derivative of y with respect to x. So you're getting that inner x by attacking on this next term. Now, what is the slope of the tangent line? Well, the slope at any point is dy over dx, and we're trying to find it at x equals 2 and y equals 1. This is just a term for at, okay, and or a way of signifying that. So we take the derivative with respect to x to the entire function, and then what we get is 2x plus y squared plus 2xy dy dx, because we derived this inner term, and then plus 2 dy over dx because we're implicitly differentiating this again. And also you bring the d over dx operator to all terms including constants, including 8, and that equals 0. If we move on here, we will have this term. So I brought these terms over here, factor out the dy over dx, and then we take this and we divide this by this, and then we will end up with what we'll just call equation 1. And with this is where you plug in the x equals 2 and y equals 1. So dy over dx at x equals 2, y equals 1, we are going to get negative 1 squared minus 2 times 2 over 2 times 1 times 2 plus 2. And the slope of the tangent line at 2, 1 will be negative 5 over 6. All right, that should answer your question. Any comments, just leave them on Wyzant. Thanks for watching.